Okay, yesterday, right, we discussed about question one. Question one is related about structural formula. Okay, as you know, right, there are three types of structural formula: condensed structure, and then expanded structure, and skeletal structure. So question number one, the skeletal structure is given. Okay, always remember for skeletal structure, you check. There is no bonding between C and H. Okay, only the others compound, for example, hydroxide, double bond O, carbon-carbon double bond, and then the C double bond OOH and Cl. Others than C and H, you have to show it. But for C and carbon and hydrogen, you just ignore, you just represent it. Okay, for example, this 1 point, consider 1 carbon, 2 carbon, 3 carbon, and then 4 carbon. So you must understand how to interpret the skeletal structure. So based on this skeletal structure, and then the question asks you to write the condensed structure. So the first one, okay, only one bonding, right? Meaning that there are another 3 is hydrogen, CH3. And then here, this carbon, only 2 bonding, meaning that another one is H2. This one, okay, 1, 2, 3, 3 bonding. So this is CH, and then there are 2 branches. One is CH3, the branches, and another one is the hydroxide. Always represent the branch by using the bracket. Okay, same for this one, question number 2. This is the branch CH3, CH3. That's why we straight away directly CH3 bracket 2, and then this carbon C. Okay, 1, 1, 2, 3. There are 3 bonding for this carbon, meaning that another one is hydrogen. Okay, and then carbon-carbon double bond. Okay, 4 bonding, meaning that there is no hydrogen for this carbon. So straight away C double bond O. You show the C double bond O. Then another one CH, CH3, CH2, CH3. I think should be no problem. And then the question number 3 is about the cyclic compound. So this is cycloalkene. That's why your drawing must in cyclic as well. And then CH, there is no bonding. Okay, due to this one, a cyclic, that's why it's like segi empat, okay, like a square. Okay, CH, CH, CH2. Okay, and then the last one, everything's still the same. Okay, for carbon number 2, this carbon number 2, there is a chlorine, and then this carbon CH2, and then the 4th carbon is a COOH. Okay, yeah. Okay. For question number 1C, from skeletal, okay, convert to from condensed convert to skeletal. Okay, I think this one much more easier. You just remember 1 carbon, 2 carbon, 3 carbon, 4 carbon, 5 carbon. So 1 carbon, 2 carbon, 3 carbon, 4 carbon, 5 carbon. Okay, so must tally. And then carbon number 4, there is a double bond. So carbon number 4, there is a double. Actually, we consider this one as carbon number 2. But right, if later you will learn about naming, right? Actually, this is C1, this one is C2. Because the carbon with functional group, right, we'll assign first. Okay, I think should be no problem for 1C here. And then this one we yesterday discussed already for question number 2. Draw the structure when a molecular formula is given. Of course, you must know what is functional group, what is homologous series, and then what is the difference between these two. So for example, okay, the first one, the homologous series is aldehyde, actually under aldehyde, ketone, right? The functional group is carbonyl. So this one, C double bond O. Okay, ketone also the same, C double bond O. The difference between ketone and aldehyde there is a H. That's why aldehyde always at terminal. Okay, carboxylic acid, COOH. Amine and H2, it can be NH or N only. Depends the class of the amine. Okay, the concept of the class of the amine is the same, primary, secondary, tertiary, based on the number of carbon attached to it. Okay, and then this one is amide. This one is alcohol. Okay, this one C double bond OCOC. Ester. Okay, the functional group is carboalkoxy. And then COC, ether, the functional group is alkoxy. So you must know the difference between functional group and the homologous series, and then you can identify the functional group and give the functional group name correctly. Okay, okay, so let's check again. Question number 3, identify the functional group. This is the way to circle. This is benzene ring, alcohol, amino. Okay, yeah, and then this one benzene ring as well. Okay, alkoxy. Okay, you check this one. Actually, right, this one, Madam prefer you all actually is C double bond O N should be like this. Yeah, like this is enough already. C double bond O N H, double check, carboxylamide. Okay, no need to include the CH3. Okay, check. This one, carbonyl, carbon-carbon double bond, benzene ring, halogen, carbon-carbon triple bond, and then you have C double bond O, COC. Okay, actually like this. Okay, C double bond O, COC. So this one is ester. Ester is carboalkoxy. And then COH, carboxylic acid, but the functional group is carboxyl. And then C double bond O, okay, this one is carbonyl. Okay, the homologous series is aldehyde. Okay, any question for the part 1 and part 2? Part 1 is about the structural formula. Part 2 is about the functional group. Class, clear? Hello?
Okay, madam.
Madam,
Yap, ada soalan?
kan kalau soalan ni,
Hmm.
saya tak ada beberapa macam saya tak bulat, saya tak tanda. Saya tanda contoh daripada sini ada 2, 4, 6, 7. Saya tanda
8.
sini ada dalam 5 macam tu je. 5.
Okay,
Salah ke
contohnya.
betul?
Okay, contohnya kalau dia 4 markah. Contoh 4 markah maksudnya 2 1 markah. Kalau you hanya 5 je, maksudnya you dapat 2 markah je lah. Faham?
Okay. Faham madam? Okay madam.
Okay Untuk soalan macam ni kan you kena bulat dengan betul. Lepas tu you bagi nama dengan betul. Berhati-hati. Tengok soalan nak homologous series ke functional group. Okay, kalau you tak nak label 1, 2, kalau you terus point out macam ni pun boleh. Okay, so you point out, bagi nama, this is carbonyl. You point out, this is carbon-carbon double bond. Okay, you point out, this is benzene ring. Cara jawab macam ni pun terima. You point out kat sini, this is halogen. Carboxyl pun boleh. Okay Okay, nanti assignment kan, untuk part 1, you gonna draw, based on your structure, you draw the skeletal, condensed and expanded. Kemudian cari carbon dia, classification primary, secondary, tertiary or quaternary. Lepas tu hydrogen pun sama, kena identify the class of hydrogen as well. Part 2, jawab macam ni lah. Berdasarkan struktur anda, identify the functional group macam ni. Ya? Okay, mari kita pergi seterusnya isomer. Okay, question number 4, as we discussed yesterday, right, based on the structure C4H10, right? Am I right? I opened my book first. C4 H10O. Okay, C4H10O. So you can draw alcohol, 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 alcohol. So there are 4 structure for alcohol. Okay, another 3 structure for alkoxy. So as you know, right, the relationship between alcohol and alkoxy, alcohol and ether means the hydroxyl and alkoxy is functional group isomerism. That's why functional group isomerism, right, dia banyak. As long as any alcohol with ether, then consider as functional group isomer dah. Okay, banyak Jadi madam semalam dah beritahu dah, dia boleh 1, 5, 2, 5, 3, 5, 4, 5. 1, 6, 2, 6, 3, 6, 4, 6. 1, 7, 2, 7, 3, 7, 4, 7. So semua sila listkan Please list all the functional group isomer. Okay. And then positional isomer. Positional isomer means position of the alcohol change. So you tengok 1, 2. 1, 2, yes. The OH attached to C1, but this one the OH attached to C2. The change still the same. Okay. You have to remember for the positional isomer, the change. Okay, this change still the same. Okay, 5, 5, 6, 5. Okay, 5 like this. The change is like this. And then this one, the change also straight change, but the position of the functional group change already. Okay, the position of the functional group. Okay, this one, C1. Okay, this one at C2. Okay, so position C2, this one C1. And then 3, 4. 3, 4. Okay, 3, 4. Yes, you see, the branch is the change is the same. The change is the same. But this one at C1, this one at C2. Okay, so these 3 pairs, right, consider as positional isomer. Okay, now we go for change isomer. Change isomer is the functional group at the same place, but the change is change. Okay maksudnya, okay, rantai dia, functional group dia tetap kat posisi yang sama, tapi rantai dia bertukar. Contoh yang 1, 4. 1 dan 4. Nah, C1. Ini pun tadi cakap C1. Tapi rantai berubah. That's why 1, 4 ialah change isomer. Okay, tengok 2, 3. Ni C2. Ini pun kat C2. Tapi change dia berubah. Ini lurus, straight change. This one with branch. This one is straight change. This one is branch. Okay, another one is 5, 7. 5, okay, straight change. C1. 7, okay, you see, this one C1 as well, but the branch is changed. So, any problem for the structure, for the constitutional isomer or structural isomer? Clear? Yeah. If clear, right, now we proceed for question number 5. Okay, who's turn to present it? Okay, now it's your turn to present question number 5. Hello. M5T21 yesterday madam assigned already, right? Who are in
Yes,
charge?
madam.
Who in charge for question number 5 presentation? For each of the following compound, draw its isomeric pair to represent a change, position, or functional group isomer. The concept exactly same as question number 4. Just question number 4 in general, you have to draw all the structure and then identify it. Okay, question 5 also the same. Okay, Putri Nuai, yes. We left the group already, Putri Nuai. Boleh tak madam tahu siapa soalan 5 semalam? Jangan macam ni ya.
Kishan.
Huh? He's not here.
Maybe he got life problem.
Okay, then I have to cover for him. Okay. Okay, I still present, right, class?
Yeah, madam.
Yes, madam.
Yes.
Yes,
Okay,
madam.
let's go for question number 5. Okay, question number 5. Okay, change position and functional group isomer. Okay, so the first question, right? There is carbon-carbon double bond. If there is a carbon-carbon double bond, right, meaning that for sure there is positional isomer. Okay, that's why the first one C1, and then the second one is started from C2. The carbon-carbon double bond at the C2. So this is positional isomer. Okay, of course you can draw it like change isomer. Why? Because right, this one, if you check, is if you cannot see the structure over here, you try to expand, you will see, okay, C, and then here C. Okay, double bond is like this. Okay, the initial one is a straight change, and then this one, the change there is a branch. So this is change isomer. Okay, when there is a carbon-carbon double bond, you must know the functional group isomer is with the cyclic compound. So this is alkene, butene, and then this is cyclobutane. So this one is functional group isomer. So you have to answer like this. Any question for question number 5A? Clear? Boleh faham 5A?
Yeah, madam.
Okay, 5B, no functional group, just C and H, meaning that we cannot draw the positional isomer or functional group isomer. Okay, for example, during assignment, right, if you get a compound that is no functional group, okay, you cannot identify the functional group for homologous series and functional group, and then you cannot draw the structural isomer. Then you just explain because there is no functional group, that's why it cannot form the positional isomer and functional group isomer. So for this question only, change isomer. Here, okay, change isomer. So this is with 1, 2, 3, 4, 5. This is 5 carbon straight change. While for this one is 1, 2, 3, 4. 4 carbon straight change with 2 branches. This one only with 1 branches. Here. When you answer this question, right, up to you. You can draw in expanded, skeletal, or condensed, because the question didn't request any structure, so you can draw anything. If you're familiar with expanded, you just draw expanded structure. Yeah. Now we proceed for C. Okay,
Madam,
C. Yes, anything?
can six carbon straight chain.
Sorry, not clear. Pardon, please.
Then the whole carbon is in one line.
The whole carbon in one what?
Line. Line. Like straight.
I understand what you say. Okay. Can 1, 2, 3, 4, 5, 6, right? Meaning that you draw hexane, right?
Yeah.
Okay, hexane, and then you have to double check the number of carbon and then the number of hydrogen. Is it tally? Well, you draw, okay, 1, 2, 3, 4, 5, 6. Okay, hydrogen 1, 2, 3, 4, 5, 6, 7, 8, 9, 10, 11, 12, 13, 14. So we check for this one. 3, 3, 6, 7, 10. Okay, can, no problem. As long as when you draw the structure, right, having the same molecular formula, yes, you can. Okay, good. Okay, you can draw the straight change, like this, for the change isomer. Okay, you can draw in butane, pentane, or hexane. No problem. Okay, yeah. Okay, now we proceed for question 5. Question 5, just now I want to explain, right? Okay, OH. OH is alcohol. Alcohol, you must take alert. It has functional group isomer with ether, like question number 4. So this is the change isomer. You just change the change. Okay, OH still at the C1, but the change is changed. Okay, can be more than one answer because if we can draw. Okay, here is 4 carbon with 1 branch. This one is 5 carbon. You can try for 3 carbon with 2 branches. Also can. Okay, and then next is about the functional group isomer, alcohol. And then this one, COC. And then the last one is position because it is C1, now change to C2. Okay, recap a bit. Just draw its pair, isomeric pair represent. So this question just what isomeric pair. So you give one answer is enough. So position, change, functional group. And then this one just have change. Then this one change, functional, positional. Okay. So we have done for the isomer for the first part, which is constitutional isomer or structural isomer. Now we proceed for question number 6. Question number 6 is about geometrical isomer. So what are the essential requirements for molecule to inhibit cis and trans isomer? This is what I told you yesterday. First, restricted rotation, carbon-carbon double bond in alkene, or carbon-carbon single bond in cyclic compound. This is the first requirement. The second requirement, right? Okay, each carbon atom of a site of restricted rotation must have 2 different groups. Okay, if you base on my slide, right, you notice I'm doing something to show you. Okay, must has different. Okay, so the first question, the question number 2B, which of the following compound can exist as a pair of cis-trans isomer? Okay, class, number 1 can or cannot?
Boleh.
Boleh. Nampak tak color madam? Kuning, hijau berbeza. Yang penting mesti ada double bond ataupun cyclic. Semua pun ada double bond. Ni pun ada double bond, double bond, double bond, double bond, double bond, double bond. Ini cyclic. Maksudnya syarat pertama semua dah penuhi. Kerana lepas tu kita kena tengok syarat kedua. Ini boleh ke tak? Number 2?
Boleh.
Yes, number 2 boleh ya. Nampak madam highlight. Number 3 boleh tak?
Tak boleh.
Tak boleh. Nampak tak H2? Maksudnya dia ada H sama. Tak boleh. 4 boleh?
Tak boleh.
Tak boleh. CH3 sama. 5 boleh?
Boleh.
Boleh ya.
Boleh.
6 tak boleh. Okay, ini boleh. Ini boleh. Okay, so sekarang siapa yang present soalan ni? Madam nak tengok soalan 1, 2, 4, 5 dan 7. Macam mana you lukiskan cis-trans isomer dia? Okay, so whose turn?
Saya.
Okay, tunjukkan jawapan anda. Silakan. Anis Ashifa.
Dah.
Cuba.
Saya boleh tunjuk satu-satu je madam.
Tak apa, you tunjukkan je. Share. Madam tengok jawapan ni macam mana?
Dah kan saya dah present dah.
Madam tak nampak. Yang lain nampak ke tak?
Tak.
Tak nampak madam.
You kena tekan present now
Saya dah tekan tadi.
Okay, sekarang you dah tekan. Okay, ya nampak skrin anda tapi tak nampak jawapan lagi. Okay, yes, okay. Okay, yes, cis isomer, trans isomer, cis isomer, trans isomer, not possible, not possible. Okay, yang kelima trans. Jangan terlalu cepat, madam sedang tengok. Turun sikit, stop. Okay, ya, saya tengok. Okay, CH3, HH, CH2, CH3. Okay, very good. Next. Tak ada. Oh, okay, cis trans. Okay, soalan 7 cara tu lukis tu kurang tepat. Yang lain okay. Okay, so good try, Anis. Okay, so yeah. Okay, semua orang tengok. Jawapan Anis tadi tu okay. Hanya yang last kali tu je. Okay, last. So this is mine. So just now Anis success to draw the cis trans isomer for the first 3 question. Very good. Okay, alert hydrogen. So this is cis. Okay, you actually right, if you know the name of the structure, you have to give the full name for the structure. We are going to learn this at chapter 5 already. Once we know the naming, right, we have to give the full name. Okay, cis 1,2-dichloroethane. For this one is trans 1,2-dichloroethane. Okay, everybody please jot down. And then this one, cis 1-bromo-2-chloroethane. This one, trans 1-bromo-2-chloroethane. So I think now you should know what is the difference between trans and cis already. Cis is the site with 2 similar molecular mass or same atom or group atom. Okay, so for example this one, okay, you might tell me, oh madam, bromine and chlorine is different. Actually, right, if you compare bromine and chlorine and hydrogen, right, okay, bromine and chlorine heavier in terms of what? Molar mass. So this one is cis. Yeah, and then for this one, okay, please take note. While there is CH2, CH3, right, make sure the bond is attached to CH2. Jangan pergi attach CH3 kerana dia memang ikat kat CH2. CH3 sudah penuh, you tak boleh ikat dengan dia. Okay, so this one is cis and then this one is trans. Okay, mengapa madam kata last kali kurang tepat? When you draw the cis trans for cyclic compound, you have to represent like this, a straight change. So this one is trans, this one is cis. Clear? Semua orang betulkan? Even there is a cyclic compound, for example, cyclopentane. Yeah. Okay, for example, cyclopentane. If you want to draw the cis trans, how to draw it? It's difficult for you to draw like this. So actually, you have to transform it like this. Or you transform it like this, yes, you can draw the straight chain. You can draw the straight chain to represent the cis trans. So for example, Cl, and then hydrogen. So this is the cis isomer. Clear?
Clear madam.
Okay, madam dah ajar cara macam mana lukis cis trans kat cyclic compound. Okay, so now we proceed for question number 7. Draw all the possible isomer for alkene. Identify the structure that exhibits cis trans isomer. Okay, whose turn?
Mine.
Okay, try to present. Share your screen, please. Okay. Madam, stop present first. Mingy, raise up your hand. Okay. Mingy, present.
So this is my answer.
Wait, Mingy, no, the screen not here. Maybe you can rotate your screen, make it become horizontal. Or if not, right, then you zoom your answer. Okay, this one clearer. Okay, good.
The first structure can be cis or trans.
Haha, okay. Okay, cycle. Okay, Mingy, try to read the
Yes.
question again. Try to read the question again. The question one, alkane or alkene?
Alkene.
So you know your mistake already?
Yeah.
Okay, so you try to show your structure with carbon-carbon double bond. Okay, class alert soalan C5H10 dia nak alkene sahaja, means double bond sahaja. You tak boleh buat cyclic compound untuk single bond. Kalau you buat single bond, okay, tadi kalau soalan tak request untuk alkene, yes, can be cyclopropane, cyclobutane. But this question asks about alkene. So, okay, never mind. You zoom your answer for C double bond C.
Which one? I don't have one got double bond.
Okay, trans 2
This one.
pentane, cis 2 pentane. Okay, you only show one. That's all.
Just two
Okay,
only.
meaning that she answer for the second part, identify the structure that inhibits cis trans isomerism. Maksudnya part pertama Mingi dah jawab, tak jawab. Part kedua dia jawab. Okay, never mind. Good try. Okay, let's check with my answer. Here. Okay. Class, be careful because this question one about alkene. Please highlight alkene. Okay, jadi soal jawapan you mesti dalam C double bond C sahaja. And then second question, identify the structure inhibit cis trans. Okay, so based on here, the basic one should be, okay, the first one. Student most properly will draw the first carbon C5H10 like this. And then change position, okay, to C2. After that, remains C1, but there is a branch. Okay, and the second one is, there is a branch as well, but the carbon-carbon double bond move to C2. Okay, another one. Okay, what is this? C double bond C, the first carbon. Okay, and then the branch CH3. Okay, alert. This one, the branch at the C. Okay, wait. This one C1, C2, C3. So the branch for this carbon at C3. C3, but this one, the branch of the carbon at C2. This one C2. Okay, this one at C2 as well, but the carbon-carbon double bond is C1. This carbon-carbon double is C2. So that's why total there are 5 isomer for alkene C5H10. Okay, based on this 5 structure, you have to identify which one can form the cis trans. Okay, the first requirement, all with carbon-carbon double bond. That's why no problem. Check for second requirement. Here, second requirement check. H2, tak boleh dah. Sini pun H2, tak boleh dah. Sini pun H2, tak boleh dah. Yang ini, CH3. Sama pun tak boleh dah. That's why hanya struktur 2 boleh je. Struktur 2 tengok. Hydrogen. And then another one is CH3. Another one is CH2, CH3. So that's why only structure 2 can form the cis trans isomer. So 2-pentane has cis trans isomer. So the mark will be given when you answer 2-pentane has cis trans isomer. Then you have to draw. Okay, this one says 2-pentane. This one trans 2-pentane. Clear, class?
Yes, madam.
Okay, jot down.
Madam nak tanya.
Jap, tanya.
Sebenarnya kan bila je kita kena buat line untuk branch tu dan bila je kita kena buat bracket sebenarnya?
Oh, up to you. Sebenarnya kalau you buat bracket macam ni kan, okay, contohnya soalan ni ya, you buat bracket ni, okay, betul lah. Okay, I faham concern you. Mungkin you akan, semalam madam dah beritahu, kalau boleh you buat skeletal, condense, content, expanded. Okay, that's why kadang-kadang kerana soalan ni dia bukan request untuk structural formula. Jadi you boleh buat ni supaya you nampak. I tahu masalah you tanya, okay? That's why you nampak kat sini ialah branch. Jadi you confused. Oh, ni bukan condense, tapi ini pun bukan expanded. Macam struktur salah. Okay. Kalau buat isomer, kalau bukan soalan tanya pasal structural isomer, yes, you can. Faham tak? Okay. Kerana soalan semalam, soalan 1 dan 2 ialah pasal structural isomer. Jadi kita kena emphasize cara macam mana lukis structural isomer dengan betul. Okay, sampai sini soalan 7, dia nak isomer. Jadi you untuk membantu anda nampak dia satu branch, 2 branch kat sini, that's why you bukan expand lah, you hanya tunjukkan, keluarkan sini ada satu branch. Kalau you tak familiar, tak apa, you boleh bracket je. You bracket CH3 pun tak salah. Okay, tapi you kalau you bracket CH3 takut you tak nampak je. Contoh macam ni. Jadi dua-dua pun terima untuk part ini. Okay, madam ulang Kalau soalan bukan tanya pasal structural formula, okay, you buat condensed structure, kemudian you keluarkan C ni. Okay, boleh terima boleh terima. Okay, faham?
Faham, madam. Thank you.
Okay, good question, good. At least you alert something. Okay, good try. Okay. Okay. So kalau tak ada soalan, mari kita sambung soalan 8. Soalan 8 ni lagi. Okay, question number 8 is compare the boiling point for the cis and trans and melting point for the cis and trans. Okay, so for here, right, cis isomer, higher boiling point. Due to what factor? Polar. Okay, kalau trans, non-polar. Okay, so we compare in terms of the van der Waals forces. Okay, polar molecule has higher boiling point. Okay, wait for a while. Okay, class, sound clear?
Clear, madam.
Okay, good. Because I changed using microphone. Okay. Okay. Now you check. So based on this, based on the isomer 1,2-dichloroethane. So this is cis 1,2-dichloroethane. Okay, this one is trans 1,2-dichloroethane. Okay, this one is non-polar. Why? Because it cannot cancel off. Okay, here I go to here, cannot cancel off. But this one cancel off. Okay, up, down, cancel off. Here also the same. Cancel off. Okay, that's why trans is non-polar, lower boiling point. Okay, but when we go for melting point, it's another explanation. Okay, melting point, trans has higher melting point. Why? Because more closely packed in solid lattice. Why say like this? Because if you check, right, the mass of chlorine and hydrogen, satu berat, satu ringan, match. Satu ringan, satu berat, match. Jadi kat sini dia boleh closely packed dalam bentuk lattice, solid lattice. That's why trans isomer has higher melting point. Peleburan, takut peleburan untuk trans lebih tinggi kerana dia rapat. Okay, rapat disusun. Can always remember cis higher boiling point. Boiling point means dia kena pecahkan ikatan untuk dari solid jadi dari liquid jadi gas. Okay, polar, stronger boiling point, stronger van der Waals forces. Trans, higher melting point because more closely packed in solid lattice. Okay, boleh terima? Okay, next we continue for question number 9, chirality center. Okay, so chirality center is a sp3 hybridized carbon with 4 different groups attached to it. Okay, now we check for the presentation. Whose turn? Okay, whose turn? Present question number 9. B.
Me, madam.
Mingyi, you got question to ask?
No, I'm present number 9.
Oh yeah, Iza present number 9. Okay, because Mingy pressed the raise hand.
Oh.
I thought he got question. Okay, Iza, let's present now. Okay, very good. You find your own information. Okay. Madam nampak you cari ada nokta sendiri. Bagus.
Okay, I present number 9, B1 and B2.
Okay, B1 and B2. Okay. Zoom sikit, Madam tak nampak. Tak jelas. Zoom sikit. Ataupun you rotate it. Okay. Yes, very good. Yes. Clear.
Number 9, B1. The compound is not optically active because there is a same group attached to the carbon.
Yang mana ialah same group dia?
CH3.
Okay. Sekejap betul Iza, tapi Madam nak beri advice sikit. Cara you lukis struktur. Semua orang tengok tengok struktur Iza. Okay, dia nampak macam betul. Okay, sebenarnya dia salah. Why? Okay, first point, you tengok tak? C kena ikat dengan C. C you tak boleh ikat dengan H. Ini ialah pantang larang semasa you buat lukisan. Okay, nampak tak? C, okay, CH2, CH3 dia sepatutnya C dia kena ikat dengan CH2 tu. Okay, another one yang bawah tu CH3 dia kena ikat dengan C juga. Okay, kedua. Soalan ada double bond ke tak? Patah balik. Okay, soalan satu ni ada carbon-carbon double bond ke tak?
Ada.
Tapi struktur you ada ke tak?
Tak ada.
Salah juga Okay, faham alert Okay, alert So, jadi you kena tunjuk double bond juga sekiranya struktur asal you ada double bond. Okay ini dua kesilapan Okay, next B2.
B2, the compound is optically active because there is 4 group attached to the carbon.
Okay, struktur ini pun kesalahan yang sama CH2, CH3 tu kena ikat dengan C Okay, lagi. You beritahu saya ini optically active, tapi you tak tunjuk carbon yang mana ialah optically active. You kena represent dengan R straight. Nanti Madam tunjuk apa tu R straight Okay, good try. Next. 9B, 3 and 4. Thank you, Iza. Who is the next?
Okay, madam.
Okay, Mushida.
Ada ke madam?
Nampak tapi zoom sikit. Ataupun you rotate, zoom. Ataupun you rotate dia sebagai horizontal, lebih jelas. Sekarang nampak tapi tak jelas sangat. Okay, yes. Okay. I rasa zoom lebih sesuai kot. Kerana nampak sementara masih tak clear. Sekarang nampak tapi dia melintang, bukan dia vertical. Okay, tak apa Madam tengok jawapan. Okay, macam ni lah dia. Okay dah, macam ni lah. Terangkan. Sila terangkan. Yeah, Mushida, you may start now.
Madam, tapi saya kurang faham macam mana nak identify dia punya optical active tu.
Optically active tu asalnya dia ada chiral carbon tu optically active. Jadi struktur nombor 3 ada ke tak?
Ada.
Apa tu chiral carbon? Ada apa tu chiral carbon? Yang first kali you kena tahu apa tu chiral carbon. Mushida jawab soalan madam, apa tu chiral carbon dulu?
Chiral carbon, sp3 hybridized carbon atom with 4 different group attached to it.
Okay, apa maksud dia sp3 hybridized carbon?
Maksudnya ada 4 single bond.
Okay, boleh. 4 single bond. Lepas tu syarat kedua ialah?
4 different group.
Okay, 4 different group. Okay, jadi you tengok soalan yang 3. Okay, dia ada tak yang sp3? Maksudnya semua 4 single bond. Lepas tu ada chiral carbon. Sorry, 4 group yang berbeza. Tapi kan, ya ke? Tak pasti. Okay, tak apa. Madam tolong presentkan. Mushida kena dengar betul-betul.
Okay.
Everybody please pay attention now if you're not clear the concept about chiral carbon yet. Okay, the first requirement must contain a chiral carbon for the enantiomer or the optically active compound. What means by chiral carbon? sp3 hybridized carbon with 4 different group attached to it, not superimposable with its mirror image. So look at here. The carbon, right? Okay, just now I mentioned Anis, right? Maybe Anis I forget already. Must show the chiral carbon with asterisk. So this is the asterisk. This one is the asterisk. And then must be 4 different group or atom, P, Q, R, S. Okay, must draw in 3-dimensional way. So this is point out, this one is point in. Okay, the dash point out, this one point in. So P, Q, R, S must be different. So must be mirror image. Means when it reflect, right? Okay, we'll get the same thing. So for example, this one. Okay, yes. Okay, and then if there is a chiral carbon, it can reflect from the enantiomer, but not superimposable. What means by not superimposable? Okay, now I open my screen and then show to you all. Okay, class, can you see me? Can?
Nampak, madam.
Okay, so mirror image is like our hand. Okay, so mirror image reflect, but it not superimposable means like this. Nampak tak? Dia tak boleh bertindih dengan rapat. Not superimposable. Okay, this one is mirror image, but not superimposable. You cuba buat macam ni. Superimposable ke tak? Takkan, dia tak boleh bertindih kan? Betul tak? Yes, Anis, try. This is not superimposable. Okay, mirror image, but not superimposable. So do not now clear about the properties of enantiomer? Boleh?
Yeah, madam.
Okay, good. Okay, so I try to use the simple way, mirror image, but not superimposable. Okay, so let's continue. Okay, so can you question 9, the share screen of question 9 clear? Did I share my screen for question 9? Hello?
Yes, madam.
Okay. Nampak? Okay, good. So, okay, chirality center, you just define it like this. And then next, identify the compound that inhibit optically active. Okay, semua orang ikut madam. Madam ajar cara senang. Ada H3, tak boleh. Carbon-carbon double bond, tak boleh kerana carbon-carbon bond bukan sp3. H3, tak boleh kerana mesti berbeza. H2, tak boleh lah. Jadi ni tak ada. Okay, struktur kedua. CH3 tak boleh C ini kerana H3. Okay, yang ini mungkin. Okay, jom kita cuba tengok. Hydrogen satu group. Hydroxyl satu group. CH3 satu group. CH2, CH3 satu group. Jadi adakah 4 grup yang berbeza ikat dengan C tu?
Ya.
Mushida faham sekarang? You tengok carbon ini ada 4 grup. Madam dah represent dengan color yang berlainan. Boleh? Jadi ini
Boleh,
ada.
madam.
Okay, that's why carbon ini ada. Tengok tak? Madam represent dengan asterisk. You kena represent dengan satu simbol ni asterisk. And then you boleh lukis enantiomer. Okay, nampak tak enantiomer dia? Reflect. Point out, point in, kemudian okay, reflect lah. So, jadi enantiomer mesti label. If the question asks you draw the enantiomer, so you must draw a mirror over here and then the reflection. Okay, question number 3, why cannot? H3 tak boleh lah, H2 tak boleh lah, H2, H3 memang tak boleh. Kemudian you mungkin akan tanya, oh ini C boleh lah, but please be careful. Why? CH2, CH3, CH2, CH3, same group. That's why cannot. That's why cannot. Okay, and then this one, H3 cannot. Okay, this one, C double bond O cannot, but this C, yes. So that's why this C is the chiral carbon, must represent by asterisk, and then you try to draw the enantiomer like this. Okay, so now do you clear about what is enantiomer? How can the compound be optically active? Must have chiral carbon. Then you must know how to identify the chiral carbon. Once you identify the chiral carbon, you must know how to draw the enantiomer, reflection. Okay, any question about question 9? Hello? Hello, class?
Ya, madam.
Okay.
Tengah, ada soalan tak? Untuk soalan 9.
Why got OH1, madam?
Oh, sorry?
Why
Oh,
the...
yeah. So, okay. Sorry. It's copy and paste problem. So, suppose this one is CH3. Thank you. Okay.
Thank you.
Okay. Thank you. Copy, paste, and problem. So, this one is CH3, CH3. Good. Okay. For certain people, right, they will quite typical. Why I say so? Because they will draw like this. The C should be here, the H should be here, but it doesn't matter. Okay, maksudnya ada orang nanti akan buat macam ni. COOH. Betul-betul bandolan. Okay, tak salah juga boleh. Kalau you nak typical macam tu, boleh je. Tapi sebenarnya tak perlu pun. Okay. Okay. Good. Okay, I check If Amanda want to ask, right, later 9 o'clock got class or not?
Got, madam. Yes, madam.
Oh, okay. So I have to be fast for the last question. Question 10. Okay. Now I share for you all. Okay. Question 10. Structural features of a molecule in order to be optically active. So as I say just now, must have chiral carbon or chirality center. Okay, it's a sp3 hybridized carbon with 4 different groups attached to it. And then the second requirement, mirror image, not super impossible. If the question asks about the requirement for enantiomer, okay, the compound to be optically active, actually the answer is the same. Okay, number 2, draw the structural formula 2-bromo butane and indicate the chiral carbon using an asterisk. So you draw the structure. This is 2-bromo butane. And then you identify, okay, based on the method I teach you just now, this one CH3 impossible, H2 impossible, H3 impossible. So yes, this one. If you check, right, there are 4 different groups: hydrogen, bromine, CH2, CH3, and CH3. So have to put the asterisk over here to show that this carbon is a chiral carbon. Then use 2-dimensional formula to show the enantiomer. Okay, this is it. Remember, must label enantiomer. And then this one is point out. The dash should be like this. Point out. Okay, and then this one must in black color. Okay, point in black color, point in. So that's all for enantiomer. So this is under diasteomer. Diasteomer, there are enantiomer and cis trans isomer. Is it? Oh, no. Okay. Diastereomer is referred to geometrical isomer. Okay, so always remember, right, you have to check this one. Okay, you have to check with this table. For isomer, you have to always check with this summary. Okay, yes, this one. Okay, so just now we learned about structural isomer or constitution isomer. There are 3 change isomer, positional isomer, and functional group isomer. And then stereoisomer, there are 2 diastereomer and enantiomer. And then the diastereomer actually same as geometrical isomer and cis isomer. Okay, that's all for today. Start from question 11 and 16, right? Okay, you can refer to my the summary video I already discussed for 11 until 16. If you got question, you can PM madam, or we continue our discussion on next Thursday. Okay, thank you, class.
Thank you, madam.
Thank you, madam.
Thank you,
Thank you,
Adam.
madam.
Thank you, madam.
Remember, complete your tutorial chapter 4. Remember, complete your tutorial chapter 4 included objective question. Okay, bye.
Bye, madam. Thank you, madam.
Okay.